Okay, in the previous session, you discussed about the IoT devices and then some of the example for the IoT devices. And then we discussed some of the concept regarding the Raspberry Pi and different interfaces for the Raspberry Pi. Now we are going to know about the Arduino interfaces. Here, what is the Arduino board? What are the components of Arduino board? And then what are the functions of these components? I'm going to explaining this information. If it comes to the Arduino board, see here, Arduino board appears like this. Here, what is the Arduino board? I'm removing this one. Here, what is the Arduino board here? The Arduino board, this one is a Arduino board. Here, the Arduino board is a open source software and hardware platform. And then it is a some having the own IDE. Here, if it comes to the interfaces for the Arduino board, here this interface you call it as a this one. Here, power USB, and then other one is a this one is a some power barrel jack, and then if you comes to here, this is a voltage, the voltage regulator, and then if you comes to here, this one is a crystal oscillator, and then you have a different pin reset pins are there. Here if you come to here, here one is the reset pin, and then there is a reset button is there. This one is a reset button, this one is a reset button, and then if it comes to here, here to here, some of the 5 to 9 some voltage and then ground pins. Here you will find out the voltage and ground pins here, and then comes to the some of the analog pins are there. These pins are called as a analog pins, and then coming to the these are all analog pins. This one is a microcontroller. This board indicates the microcontroller. I can explain you the functionality of each and every later. This is a microcontroller chip, and then ICSP pins are there. These are all call it as a ICSP pins, and then there is a LED indicator is there, and then there this one is a you'll identify the TX and RX. Here this is a TX as well as the RX LEDs, and then there is a digital IO pins. These are all called as a digital IO pins. 14 digital IO pins you will identify here, and then analog reference. One analog reference pins are there. Totally 17 different interfaces available in a Arduino board. This Arduino board is a freely available open source hardware and software environment, and then it's having the own IDE. Here this is implemented by using a C++. That means you will write a word programming by using C++ code. That is a something about the Arduino. If it comes to the this is a Arduino board. Some information related to the Arduino board, and then coming to the Arduino. What is the Arduino board? And then what are the information regarding the Arduino board kit? Here, what is an Arduino board? It is an open source hardware software platform. Arduino is defined as it is a microcontroller board. This is called here simply microcontroller board. This is help to make the project simpler. For example, some of the so it is easy to store. That means just like it's a works just like a computer. And then this was developed to create a microcontroller kit, which was used to build electronic devices. What is the main purpose of this Arduino kit here is for creating the more number of electronic devices here. By using these devices, you will creating the more number of IoT devices. So many IoT devices we will build and design by using this type of Arduino kit. Here the most Arduino kits are comes with the 8-bit microcontroller. The microcontroller here is an 8-bit here, and then it's having the flash memory as well as the static random access memory. Here, what about the flash memory and static random memory here? And then 32K bytes flash memory is there, and then 2K bytes SRAM available in this Arduino kit. And then Flash memory consists of stored state of Arduino, while SRAM manipulate the processing of variables. Here, that means you are defining different variable. In order to processing those variables, you are using this information. This is some information regarding the Arduino code. And then the Arduino promotes a C++ as a primary programming language. Here you are using the C++ primary programming language. Here it's not having any operating system, no operating system here. Here that means the software requires either Windows or Linux, Mac OS operating system to run the programs here. Here, if you comes to the Raspberry Pi, the Raspberry Pi consists of not there is a separate slot for the operating system. That means in that slot you insert a SD card, and then you will do some. That means you may work on Linux operating system. Raspberry Pi. If you comes to the, you require Windows or Linux, Mac OS operating system to run a programs. That means most probably that means you are using C++ programming language for writing. That means there is a separate IDE is there for this Arduino interfaces. And then the type of Arduino, you have a different types of Arduino available. You have a n number of, for example, Arduino Uno. That means you are using the Arduino Uno, and then Arduino Nano, like the different boards also available. And then started kit for the beginners, Arduino Shield for the printed circuit expansion board here. And then standard Arduino boards, and then boards with advanced features also available. Here Arduino runs a single piece of code over and over again. And then due to this, that means you will run only single piece of code. It starts quickly as soon as you on power. That means it is easy to on. And then coming to the, it's having the, already I explained you, the Arduino kit having the own integrated development environment here, which is limited to the programming interfaces. And then that means in order to running the C++ programming, you having the own IDE. And design of Arduino board consists of different controllers and microprocessors. And then some boards also includes a USB models and then serial communication interfaces. Already explained. That means this one, the already I shown you the latest one, that a latest version of Arduino board. That means some of the board consists of USB cable. That means you, in order to attaching or in order to providing interface for the, you will use a USB cable, and then some of the models and then serial communication interfaces. Here the processor speed. Here how can you represent the processor speed here for this one? Is the latest one. I am considering the latest one, 8 megahertz to 400 megahertz. The average speed in this case here is a Arduino 16 megahertz. And then coming to the project of Arduino is connected to the computer. That means computer using USB port. And then in this case you have a some of the converters also available. Here which type of converters are available here? Analog to a digital converter inbuilt in a Arduino board. Here Arduino, you know, having the 16 digital IO pins are there. 16 digital IO pins already I shown you. These are all 16 digital IO pins and 6 analog pins and power pins available. We are coming to the Arduino interfaces. The interfaces in the sense, some of the components, that means those interfaces attached to the outside the environment. Some of the components available in a Arduino interface, Arduino board. In the Arduino board, you have a different interfaces also available. That means some of the components are available. Already explained the different component. We are coming to the first component here. Here, see here, number one. The number one here is a the power USB. Here, what is the power USB? Here, Arduino board can be powered by using USB cable from the your computer. And then all you need to do, connect the USB cable to the USB connection. That means in order to connecting USB cable, you will use a power USB. And then there is a barrel jack. here Arduino boards can be powered directly from, that means from AC power supply connecting to the barrel jack. That means directly you will connect to the barrel jack. Here coming to the voltage regulator. Here what is the third one? Here if you comes to the board, here third one indicates the this one is a voltage regulator. Here what is a voltage regulator in this case? The function of voltage regulator to control the voltage given to the Arduino board. That means it is used to controlling and stabilizing the DC voltages. Here for controlling, stabilizing DC voltages, you will use a this voltage regulator, and then use it by the processor and other elements. And then fourth one is a crystal oscillator. What is a crystal oscillator? See here, the fourth one indicates the this one crystal oscillator. Here, what is the functionality of crystal oscillator? Here the crystal oscillator Arduino is dealing with the time issues. The functionality in this case, this oscillator, some of the time issues here. That means how does the Arduino calculate the time? And then by that means how does the Arduino calculate the time? By using this oscillator. And then it tells us, that means the frequency is a in particular range here. Here, this is a frequency range. That is a crystal oscillator, the fourth important component here. Here, coming to the fifth one. The fifth one in this case here is a one pin is there, the reset pin. The fourth one and seventh one are the reset pins here. Here, the seventh one is a reset button. Here, reset pin. Here, you can reset your Arduino board. That means restarting, reset. That means start your program from the beginning. You can reset button, you can use the reset button. Here the reset, you know about two ways. That means you will performing the reset operation in a two way. The first way is here is a by using reset button. Here there is a in 17 number 17 in the top. Here you will identify the button, a simple button. You will call it as a reset button. Here what is the reset button? Here you can reset the your, that means reset in the sense you will start your program from the starting. And then second, you will identify the, you can connect the external reset button to the Arduino pin. That means you will take the one button, you will connect that button to the this pin. There is a reset pin. The fifth one indicates the reset pin. That is called here Arduino reset pin. Here that means there is a label is there here. Reset. See here, reset. The label for the particular pin, there is a label here that indicates the reset pin. That means you will connect the outside the reset button, from the outside the reset button to the pin, and then you will perform the reset operation here. And then coming to the 6 to 9. Here if you comes to here, this one is a sixth one, this one is a seventh pin. And then here if you identify the some labels are there, 3 voltage, and then 5 voltage, and then ground pin, and then some other pins. Here 6 to 9. Here 6 to 9 are 4 different pins are available here. 3.3 volt pins. That means it is used to supplying the 3.3 volt. That means that's a negative, just like a simple representation, negative voltage or positive voltage like that. And then 3.3 output voltage. And then coming to the 5 volts here, the seventh pin indicates the 5 volts. Here you will identify the 5 volts pin here. The 5 volts pin here. What is the necessity of 5 volts here? This 5 volts pin, the 5 volts outputs volt supply. And then most of the component used in a Arduino board works fine with 3.3 volts and 5.5 volts. Here coming to the 8th pin. Here in this case, 8th pin here is a ground pin. Here you have a ground pin is there. Here what is a ground pin here? There are several ground pins on the Arduino board. Here any of which can be used to ground your circuit. That means you will use any one of the pin here. Here for example, here 2 different pins are there, G and D, G and D. G and D here, G and D pin, and then here is a G and D pin. that is a pin, and then win pin. This pin also used to power the Arduino board from the external power source, like a AC mains power to power supply. That means in order to providing this information, you have a different pins available. You are coming to the 10th one. Here coming, what is the 10th pin here? Here, this one, the main microcontroller pin. Here, what is the necessity of this microcontroller? The microcontroller, that means it is a that means the 10th pin, no, 11th pin microcontroller. Okay, 10th pin, coming to the, you have a different pins are there. Analog pins, that if you identify 10 here, analog pins. Here, what are the analog pins here? Arduino board having the 6 analog pins available. That means those are all the label here: A0, A1, A2, and then A5. There is a labels available here, A0 to A1. Here, what about these pins here? These pins can be read signal from the analog sensor. Analog sensor like humidity sensor, temperature sensor, and converted into digital value. Here, the main intention of sensor here is a takes a physical parameter. The physical parameter here is a sensors, or that means physical parameter here is a temperature, humidity. That means that humidity converted into digital value, the digital electrical form of data, that is called here sensor. That means activator is a different here. Activator is a takes the electrical form, converted into physical. For example, motor is a activator. What is the work of motor here? Motor takes the electrical form of data and then convert it into water, the physical form of data. That is a activator. That is a difference here. Here in this case here, you have a different pins are there. These pins read signal from the analog sensors. Here, any analog sensors, humidity sensors, temperature sensor, and then that converted into digital value that can be read by the microcontroller. That means for the reading that information to the microcontroller, you have a this pins are available, converting from one form of data to another form of data. You will use a this 10th pins, A1, A2, A3, A4, A5, and then A0. These pins read a signal from the sensor. Here, that's converted into electrical form or a digital format of data. That is called here analog pin. That is a main purpose of analog pins. Here, coming to the 11th one. Here, if you see here, the right side here, the board consists of 11th one, microcontroller. What is the main purpose of microcontroller here? Here, each and every board consists of microcontroller. Here, the microcontroller, in the sense, for example, if you comes to the computer, the microcontroller is a main brain of your computer. Is it correct or not? Brain, it's just like a brain. Here, each Arduino board has its own controller, and then you can assume it as a brain of your board. And then the main integrated circuit on the Arduino is different from the board to board. That means in this board, the microcontroller appears like this. Here, some other case, you will place somewhere else. No, that means for example, it is the latest version of board. Here, if it comes to the previous version, you will have the board in a certain other place. That means the integrated circuit on a Arduino is different from board to board. And then the microcontrollers are usually of Atmel company. That means Atmel Mega. Why? Because here this microcontroller board based on a Atmel Mega 328P data sheet. 328P data sheet here. Here, this is a open source hardware and software platform used to design and build the electronic devices. Here, for designing the electronic devices, you will use this board. This board having the brain of your, that means the brain, this is a microcontroller. And then you must know what IC your board having. And then before loading up a new program from the Arduino IDE. And then this information available on a top of top of the IC. That is a some description about the Arduino board. And then the main important thing here, they will ask, sometimes they may ask about the 3 marks question. What is the microcontroller in a Arduino board? And then what are the work of microcontroller in a Arduino board? How can you represent the microcontroller? Where you are placing the microcontroller in a board? Here, that is a simple information. The 11th one indicates the microcontroller. You are coming to the 12th one, ICSP pin, integrated circuit, and then serial peripheral pin. It is a AVE studio like that. A programming header for the Arduino. Here it consists of a MOSI, MISO. I think you know very well about this MO. That means in the Raspberry Pi, I explained about the master out slave in, master in slave out, and then SCK0, SCK1, and then reset VCC ground. Here this pin, the 12th one here in this case, here you have a 6 different pins available here. Here what are the 6 different pins here in this case? The one is a MOSI, master out and slave in pin. Here already explained that concept in a Raspberry Pi. And then MISO, another pin, and then SCK, reset, and then VCC, and then ground pins. Here you have another ground pin. That means in the second place also there is a ground pin. Eighth one, eighth place also there is a ground pins also available. Here also there is, that's why some number of ground pins available in a Arduino board. And then it is referred to as a SPI. SPI, that means the SPI means serial peripheral interface, which can be considered as a expansion of output. That means you are getting the output here in this. You are solving the output devices to master of SPI bus. That means there is a bus. You will inserting that bus in these pins. From this you will solve the problem. This is a something about the ICSP pins. We are coming to the power LED indicator. Here 13 one. Here there is a power LED indicator here. Here this one. I think this one is a 13. Yeah, this one. What is this one here? Here this pin used to light up. That means LED should light up when you plug your Arduino into the power source to indicate that your board is power up correctly. That is the main purpose here. In order to power up in your board here, you will use a LED. That means that it's an indication. Here, if light does not turn on, then there is a something wrong in the connection. That means based on this line, if a line is on, then is it's a light is on, no problem here. The system working correctly. That means it's a having the, if it is not light on, that means wrong connection is there. You are connecting the wrong, that means for the interfaces you are connecting from the external sources, some connection is wrong. Here coming to the 14th one. Here what about the 14th one here? TX and RX. TX and RX LEDs here. This 14th one, see here, TX as well as the RX. TX as well as the RX LEDs. Here what about this one here? On your board you will find the two labels, TX and then RX. Here what is the meaning of TX here? Transmit, and then RX means receive. Here this appears two places on a Arduino Uno board. Here first thing here is a at the digital pin 0 and 1. Here what are the digital pin here? The digital pin in the, if you see here board, TX value digital pin 0 and 1. 0 and 1 to indicate the pin responsible for the serial communication. Here pin responsible for the serial communication, that indicates the this pin. And then second pin, that means somewhere else also it available, TX pins here somewhere also available. That means I cannot see that one. Here there is another way. Okay, in our board you have a second TX and RX LED here. Here what about the TX and RX LED? TX LED flashes with a different speed. Why? is sending the serial data. And then speed of flashing depends upon a baud rate used by the board here. And then RX flashes burning the receiving process here. Your main purpose of this TX and RX pins here is a receive and then transmit. Here you will identify these pins in two places, not in single place here. Here at the digital pins 0 and 1. Here we will identify the digital pins 0 and 1. There is a, I think, digital pins 0 and 1. Yes, somewhere else is there digital pin 0 and 1. Yeah, you will identify here. Yeah, here is the TX and RX 0 and 1. Digital pins 0 and 1. You will identify the this TX RX pins. What is the main purpose there here? To indicate the responsible for the serial communication. And then second way, that means TX and RX LEDs, they appear in the appear as a TX and RX LEDs. Here this one is a flashing, that means LED on or off, there is a information is there. That is a 14 pin. Here coming to the digital IO pins, here 15 one. Here, yeah, in the 15 digital IO pins, in these pins here there is a 0 and 1 indicates the TX as well as the RX pin. Here this pin, two pins, the TX as well as the RX pins here. And then coming to the digital IO pins, the digital IO pins, 14 digital IO pins available here. And then 6 for the pulse width modulation output. And then some other pins can be configured to work as a input digital pins to read a logic values 0 or 1. That is a these different pins here. And then this pins label can be used to generate a pulse width modulation. Here this if you see here, the board consists of at the top consists of 14 pins available, 14 different pins. Among the 14 pins you have a TX and RX pins also available. And then coming to the next important last and final one in this case, here is a AREF. AREF means analog reference. Here the 16th pin, the top here you will identify the analog reference pin. Here what is used to set a external reference voltage. Here that voltage maybe 0 to 5 volts. Here that means as a upper limit for the analog pin. That is a simple information regarding the Arduino interfaces. Here Arduino interfaces. Here that means you will download the Arduino interfaces freely available. Here if you like, next I can show you the link for the Arduino interfaces. From the Arduino interfaces you will download that one. Here if you download that one, you will install that one in your system. There is a IDE available. In that IDE you will write your programming. That is a simple information about the Arduino. Okay, thank you.